Hello and welcome to the first part of the Calculus 1. I am Mohammad Momezadeh, the presenter of this lecture. So we just start to discuss about some topics related to the Calculus 1. We should start our discussion by the function, the basic topics of this course that we should know a lot of things about it. So we start our discussion by the basic definition. Later on we will talk about the trigonometric function and some identities will be investigated, and later on we will talk about the exponential values and the laws of that one, and if we find the time we will discuss about the exponential and logarithmic function. At the end of the day, when we prepare ourselves with this type of the topics, we go and delve to the limit of one variable functions. So I know that most of the students who take this course recently passed the high school, so we try to have a quick review about the concept of these things, and we have some topics about the algebraic and arithmetic topics as well. So let us start our discussion by the definition of a function and different types of the function that we can consider here. So this is the definition of function of a single variable. Let us take a look at that definition. Given an input x, a function f defines a recipe y equal to fx for evaluating the corresponding output of y. So up to here we can consider a function as a procedure or as a actually mapping or a law. So we can consider the function as one machine or one type of the law that we have one input inside of that law or that type of the machine. So if I just consider the input over here for that machine as a x, as a variable, single variable that we put it inside of the function, then the function over there procedure on that x, and after that processing the value of x, we have one output for that type of the machine. That output determined by y or f of x. So y or the output will be considered as f of x. So the only important thing about the function is about the output of the contents. So for one single input, we should have only one output of that machine. Means that we cannot have two output for one single input for that function. So the receipt of that function can be considered as y, and we determine it by f of x. One might also call the function receipt a mapping or transformation or an operator. There are all the name of the function, means that we can use the mapping, transformation or operator. So to demonstrate the type of the function, we can use the sets. For instance, if a is a set of some values like 1, 2, 3, and the output or the receipt or the mapping of this value is considered as another set that we denoted by b over here, and we can have some number over here as well, for instance 4, 6 and 7. Then this type of the machine, this type of the function, this type of the mapping just correspond the values at the domain or the set A to the value at the range or the set B over there. For instance, we can put them in one shape like this and put all the entries as a domain of that function that we denoted by d of f, and we put the value 1, 2, 3 over there, and the corresponding value at the right side determine the range of this function, and we denote it by r of f, the range of the function over here, and it contains the value of 4, 6 and 7. So we may take out some arrows and show this corresponding by some arrows from the domain to the range. For example, 1 map to the 4, 2 map to the 4 as well, and 3 map to the 6. So over here we correspond the value of a domain with the value on a range, and this correspondence can be considered as a function of f. Even we can determine a function by the ordered pair, means that this f or this function that we have, it can be demonstrated by some ordered pair. So at the ordered pair, the first component determine the x value and the second component determine the y value. However, for the value of 1 and 2 we have the same output. This type of the things can be demonstrate a function, because for one entry we have only one output. We cannot have two output over there. So as you can see, we can determine the function by the ordered pair, that the first component determine x and the second component determine y. If for one value like 2 we have two output, means that 2 is mapping to 4 and 6 simultaneously, then this cannot be determined a function. So it's not gonna be a function, because for instance we cannot determine the value of f of 2. So moreover, we can determine the value of each points in the domain by the words of a function, means that we can say that f, if f is working on 1, if f map the point 1, then the result is equal to 4. So the f of 1 is equal to 4 in this function. Or f of 2 over here as well can be calculated as 4, and also we can evaluate f of 3, which is equal to 6. So as you can see over here, for one input we have only one output, and for 2 we have 4, for 1 we have 4, and for 3 we have 6 as well. So we should take care to define the type of the input and output, means that the input and output are the real numbers, integers, complex numbers, or so on. So at the high school you just learn that how to deal with that type of the set of the numbers. So means that at the high school you realize the different type of the sets. One set that you learn it at the high school are the natural numbers. That natural numbers contains the number like 1, 2, 3, and so on. These numbers are called the natural numbers. Moreover, we extend this concept to the integer numbers that we denoted by z. So that integer numbers contain 0 and also the negative number. So it contains 0, plus and minus 1. The negative number also will be included in that type of the set, plus and minus 2, and so on, means that we have all these type of the numbers at the integers. We can have the another demonstration for this set with two actually infinity parts, means that we just write it as a 3 dot, then it's gonna be minus 1, then 0, then 1, and then it's going on up to infinity. These type of the numbers were called the integers. So moreover, we have also the real numbers. The real numbers are the complete points that are available in one axis, and it contains two type of the numbers: the quotient numbers or rational numbers, and also the irrational numbers that we determine it by q complement or qc. So this determine the irrational numbers. These symbols between the rational and irrational numbers is called the union. So we have the union of rational and irrational numbers. So the good part of the real number is about their completeness, means that if you consider one straight line and put one arrow at the end to show the side of the positive part of that one, and put one origin over there that we put it as a 0, and one unit like 1, then for each point inside of this line, for example this point over here, we have one corresponding real value, and vice versa. For each real number you can determine a point over the line. So means that this line contains all rational and irrational numbers together. If we extend that real numbers more, then we have complex numbers. That is not our concern in this course, means that we just work with the real numbers, but it's not a bad idea to know the definition of them. So the complex numbers are defined as x plus iy, where x and y, both of them are reals, and in this case x and y, both of these numbers are real, and that I determine the imaginary values, and by the another word that I is equal to roots of -1. However, the roots of a negative number is not defined in a real value, so in a complex numbers we have I as a roots of 1, and we can determine a number as two parts in a complex numbers. One is a real part and the another one is an imaginary part, and you should determine this point in two-dimensional space instead of one dimension. So these are some basic topics about the sets and the property of the set that most probably you remember it from the high school concepts. But over here we had a quick review about the type of the different numbers. Here we are concerned with the scalar real values, means that our concern over here is the real values, and we just discuss about this type of the actually sets inside of the calculus, means that the important part is about the real numbers. So let us take a look at the real numbers precisely and just talk about that things more over here. So as I said it before, any real valued number can be determined by two sets. I mean, one of them are rational numbers that we denoted by Q, or quotient numbers, and the another one is a Q complement, which is irrational numbers, or the numbers that cannot be demonstrated by decimals. So for the rational numbers, we can say that these rational numbers, or the quotient numbers, contains all type of the fraction. So it's equal to all type of the fraction, like a over b. We can determine the rational number as a value like a over b, where a and b, both of them are integers, and the denominator of this integer is not 0. So means that this value, that the b actually, or the denominator of this fraction is not equal to 0, is called the quotient number or rational numbers. For example, 4.3 is a type of the actually rational numbers. So this type of the number with the decimal can be determined as a 43 over 10, and as you can see, I can determine that value as a fraction. Or for instance, if I have 5.3021, then this number also will be a decimal number that is rational. So for example, over here I can rewrite that decimal number as follow. I can rewrite it as this value over 10,000. So if I just divide it over there, 1, 2, 3 and 4, 0, enough to just determine that number as the fraction. So this type of the numbers are called the quotient. However, we have the different type of the numbers as well, like roots of 2. So if you just want to calculate roots of 2, then it's gonna be 1 point something, and this type of the digits never had a repetition or never had the similar attitude. So for this reason, this type of the number like roots of 2, roots of 3, roots of 5, this type of the number are actually irrational, because you cannot find a decimal number which demonstrate the exact or accurate value of these roots. Moreover, we have some type of the number like pi that you learn it at the geometry as well. It's equal to 3.14156295 and so on, and this type of the digit will never end. You cannot find any actually attitude or any behavior of a repetition in that type of the number. So we approximate pi by this value. It's not exactly equal to these things. The another number that is important over there is a Euler number, which is equal to approximately equal to 2 point something, and this number also has a lot of digits which is not repeated or has one rule of the repetition in the actually digits. So these are the quotient and irrational numbers together. So as I said it, in one real line that we put one origin and one unit on it, we can determine that real values over there, and for each point at the real line we have one real values, and vice versa, for each real value we have 1 point on a real line or that x-axis. So we are talking about the scalar real values at the calculus. So this is the first actually things that we should consider it over here. So we can define the function as I said it by the value of that function, means that y equal to f of x, and we can mention about the domain of a function where the values over there, I mean the x over there, is valid for x and y belonging to the real value. Programmers take similar care with the types of variable and intervals of validity. So if you have ever worked on programming, or if you write any comments in any type of the program, you realize that at the beginning of the codes you should determine the type of the variable, otherwise the program will not accept your variable. So it's important to determine that variable. Let me just write one simple example over here, that for example y is equal to 2x over 3 x plus 1. This determines a type of the function. So for this function that I can name this function as f of x as well, you can see that the value of x is defined by some rules over there. For example, f at the point 2 can be calculated by replacing 2 instead of the x. So if I want to calculate f of 2, then I should simply replace x by 2. So 2 times 2 should be written at the numerator, and in the denominator of this fraction we have 3 times 2 plus 1. So we can find the value of that function over here. So by this definition, the value of the function will be 4 over 7. So we can calculate f of 0, for example, as well. F of 0, let us calculate the f of 0 as well. So we have 2 times of 0, 2 times of 0, so divided by, as I said it, you should replace the x by 0 to calculate f of 0. 3 times 0 plus 1. The result will be 0 over 1, and as you know, the 0 over 1 is equal to 0, but the number over 0 is undefined. Let us take a look at the domain of this function, means that which value are allowed to replace instead of the x. As I said it before, we can consider the function, the f, as one machine or as one procedure that we put x inside of that procedure, and the output for this type of the function is equal to 2x over 3x plus 1. The only restriction that we can consider it for this type of the function is a 0 in a denominator, means that you are not allowed to have a 0 in a denominator. So means that 3x plus 1 as a denominator cannot be equal to 0. If I just mention about that restriction, that this part is not equal to 0, then I should consider this equation. Indeed, I can shift that one to the right side. When you just have this type of the 1 degree equation, to solve that equation you should put all constant in the one side and variable on the opposite side. So the number 1 as a constant should shift it to the right. To shift it to the right, we subtract 1 from both sides, or we change the sign of 1 plus 1 to the minus 1 and put it at the right side. Means that it should be equal to it should be equal to -1, because +1 at the right side shifted to the right side. And then by dividing both sides by 3, you will find the value of x. Means that at the end of the day, x cannot be equal to -1/3. So we learn how to solve the equation of a first degree over here. As I said it before, you should put all the constant in one side and the variable on the opposite side. Then by dividing the terms by the coefficient of x, you can find the value for the x. So x is not equal to -1/3, and because of that, x is not allowed to be -1/3. Otherwise, the denominator of this fraction will be 0. So from this conclusion, you can see that the domain of this function, the domain of f, this function that we named it by f, is equal to the real values, all real values, except this value that make the denominator 0. Means that we should remove -1/3 from all real values to have a verified function over there. So this is gonna be happen in this case. So right now let us take a look at another type of the presentation for a given function. Up to now we talk about different types of a presentation for a given function. As I said it before, the function can be considered as a law or mapping or transformation of some input. And if we consider a function as a machine and we put one variable like x inside of that machine, the output of that one will be y equal to f of x, or the output of a function after we process on a given input. So we have the different type of a demonstration for that function. As you remember that if we determine the domain of a function by d of f and we put some numerical value inside of it, however it could be some another objects instead of the numbers. For example, let us put some numbers like pi, like Euler number, and also 1 as a domain of this function, and as a range of a function let us put the value -1 and -2, for example. Then for the given range and domain of a function, we should determine the function by the corresponding relation between them. We can put them in some set like this that we determine it by d of f, and we put the value of the domain over there, pi, e, and 1, and also we can make the range of a function on the other side and put the value corresponding to the range as -1 and 2. Right now, to determine or present the function, we can use some arrow and determine the values by connecting this type of the domain to the range. So right now I have one type of the presentation for this function. The another type of the presentation, as I said it, is using the ordered pair. So if we use the ordered pair, at the ordered pair we can put the first component as an entry or the x values, and the second component or second entry of that ordered pair determine the corresponding value for that thing. So as you can see, I just put the value of that function for the given values. So 1 is going to 2 as well. This is the another type of the presentation of a function by using the ordered pair. However, we can use also the value of the function over there. Means that we can write the value one by one. F of pi is equal -1, and also we can rewrite that the f of e, or the procedure of function f over the Euler number, is equal to -1, and at the end of the day f of 1 is equal to 2. However, these methods that we talk about it is totally impractical, because you cannot put all the value of the function in one line and determine them over there. Instead of that one, we can use two-dimensional space. For this reason, we should sketch one cross and determine the x and y line over there. This vertical line is called the y line, and this horizontal line determine the x value or the entry. So we can put the value of entry in a horizontal line and corresponding value of the function at the y. So for example, let us determine the first point over there. F of pi is -1. If this point determine the pi, then the value of the function at this point, at the point pi, is equal to -1. So I just make one line over here, and as much as -1 I will go down. So this point that I have it over here determine the f of pi, which is equal to -1. So this point over here is -1. So because of that, the pi and -1 disordered pair determine this point at the two-dimensional space. So for e as well, e is a number 2 point something, the value of the function is equal to -1. So we have this point as well. And for the value of 1, the value of the function is given by 2. For instance, this point is 2, and you can determine the point at this location. So in a two-dimensional space, for each ordered pair we have 1 point. So by this discussion we can evaluate, we can present indeed the function by some curve in that space. So let us consider one another example over here. If we assume the two-dimensional space over here again, and let us consider one another function that is given by the values of x. The simplest one is y equal to x, or y which is determined the f of x is equal to x. So for sketching this function, for evaluating the graph or plotting the graph of this function, you should give some value to the x and find the corresponding value for y. For this reason, I just sketch one table, one t table for instance, to determine this value. And if I just put the x value at the first row, and in a second row we can use the value of f of x or corresponding value of y over here. So right now I just put some values over there. For instance, let us put -2, -1 and 0 for the x, and then the corresponding value for y, which is the identity function, and give you the same value, means that for the x equal to -2, the value for y is -2, for x equal to -1, the value is -1, for the value 0 we have 0, and so on. So right now each of these points can be determined a point on a two-dimensional space. For example, -2 and -2, let us put these values and mesh this two-dimensional space like this, and put their corresponding values over here. So right now by putting this value you can determine the points. The point -2 and -2 is located at this position, and -1 is here. So 0, 0 is there, 1 and 1 is here, and 2 and 2 is there. So we determine the place of this point over the two-dimensional space, and if I connect all of them together, then you realize that it's going to be a line like this with the 45 degree with positive side of the x line. So this determines the graph of a function y equal to x. So as you can see over here, we have some graph of the function. If for each value of x, for example, for this value of x, we have only one value of y, by sketching the vertical line, you can cross the graph at least at one point. But if the function is multi-valued, which is not a function indeed, it's not the definition of a function, means that this type of the relation over here are not the function. So in this case, as you can see, if you sketch one vertical line, then that vertical line cross the shape of the graph at more than one point. As you can see, it's has a intersection in 2 points, and this gonna be the relation which is not a function. So for instance, the relation for this type of the graph is x squared plus y squared equal to 1, and as you can see, for some values of x we have two value of y. If you just shift y to the right side, then we have x squared equal to 1 minus y squared, and by taking the roots from both sides of this expression, you will find that the x is plus and minus. It will be plus and minus roots of 1 minus y squared. So as you can see over here, this expression has two values, one positive and one negative for each x, and as you can see, we have two output for one single input, and it's not a function. Indeed, we call that one a relation which is not a function, or with neglecting this discussion, you can call that one as a multivalued function as well. However, as I said, it's not a function. For the section C, for the part C as well, if you sketch one vertical line, as you can see, that vertical line has the intersection more than one times with that graph, and consequently it's not determine a function, or with that words we can say that it's a multivalued function. Before that, we going forward, it's necessary to somehow review the type of the algebraic expression over here. If we have the expression like a times x plus b equal to c, and if we want to solve this type of the equation, as I said it before, this is a first degree equation because the x, the maximum exponent of x is 1. To solve this type of the expression, you should put all the constant in one side, means that you keep ax at the left side and shift that b as a constant to the other side, and because the sign of b is positive, when you shift it to the left, the sign will be changed to the negative, so we have minus b, and at the end of the day, to solve x, you should divide all the terms by a, so we have x equal to c minus b over a. This is how we can solve one linear equation, or one equation of a first degree. For example, if we want to know what is the value of x for this given expression, like minus 5x plus minus 1 equal to plus 4, to solve this one, as I said it, you should shift that constant minus 1 to the right side, and when you just shift it to the right side, it becomes positive because the sign was negative at the left. So we have 4 plus 1, and 4 plus 1 is equal to 5. So we have minus 5x equal to 5. And right now, to evaluate the value of x, you should indeed divide both sides by minus 5. And if you do that one, x will be 5 over minus 5, or minus 1. So in this way we can solve the linear equation, or the equation of a first degree. However, for the equation of second degree, means that when we have a quadratic equation, this kind of the equation is called the quadratic equation, like ax squared plus bx plus c, then you should use the delta formula to calculate it. Means that you should evaluate the determination of this function. The determination, or delta, is given by b squared minus 4ac. So you should memorize these things, b squared minus 4ac, and the equation has three conditions after that one. If the delta is equal to 0, then we have only one solution. That equation has one solution. So if we have the delta is greater than 0, then that type of the quadratic equation has two solutions. Where delta is greater than 0, then we have two solutions, and if the delta is negative, there is no real solution for that type of the quadratic equation. No real solution. However, we have two complex solutions, but over here we can emphasize that there is no real solution for this case. And after that, the x can be calculated as minus b minus b, you should calculate minus b plus and minus roots of delta over 2a. This is how we can calculate the quadratic equation and find the corresponding value for the given x. For example, if I have this expression that 4x squared minus 3x minus 1 is equal to 3x minus 1 is equal to 0. So if the constant number is lay on the right side, you should shift it to the left. Otherwise, you cannot solve the quadratic equation. Right now, we should determine the value for a, b, and c. So over here, you can see the corresponding value for a, b, and c means that a is equal to 4. The coefficient of x squared is given by 4. The coefficient of x, which determine the value for b, is minus 3. And the constant part c is equal to minus 1. By knowing that type of the things, we can find the delta. Delta over here is equal to b squared, and b is minus 3, so we have minus 3 squared minus 4 times of a is 4, and c is minus 1 as well. So over here, to calculate this expression, we know that the minus 3 squared means that minus 3 times minus 3 is equal to 9, and this minus times minus make that sign as a plus. 4 times 4 is 16, and 9 plus 16 is 25. Right now, because the delta is positive, so we have two real solutions for x. And to calculate the x value, we can see that the x is equal to minus b. Minus b over here is 3 plus and minus roots of 25 over 2a, and 2 times 4 is equal to 8, so we have these values. So right now, one times we just consider the plus sign and one times the negative sign. So for the plus sign, we can say that 3 plus 5, roots of 25 is 5 over 8 is a plus solution for that one, and the another one is 3 minus 5 over 8. So 3 plus 5 over 8 give you the first solution, real solution, which is 1, and this one give you the second one, which is minus 2. 3 minus 5 is minus 2 over 8, or minus 1 over 4, and minus 1 over 4 can be calculated as minus 0.25. So this will be the solution for the quadratic equation. I hope that you remember the formula for the quadratic equation as well. So as you can see over here, we have classes of a function, and we try to introduce them only over here. Somehow it's a type of the quick review about the cases that we have it. So the first type of the function that you may face in this course too much is a polynomial function. So as you can see, the polynomial function is given by some type of the expression like this. I mean, this determines the form of a polynomial. As you can see over here, the degree of a polynomial is determined by the highest or the biggest or the greatest exponent of x, means that up to an x to the power of n, an x to the power of n can be considered as one polynomial of a degree n. We sometimes denote this type of the polynomial by Pn of x. So at the polynomial cases, we don't have any type of the trigonometric expression or multiplication between some expression or something like that. Sometimes we can multiply two polynomial to get another one as well. For example, if you have 3x plus 1, this is gonna be a type of the polynomial, and if I multiply this polynomial by the quadratic equation like x squared minus 5x plus 1, then we have a polynomial of a degree 3 at the end of the day. As you can see, the first expression or this one is a linear expression or the polynomial of a degree 1, and the second one determine the polynomial of a degree 2 or the quadratic equation. And when you multiply these two polynomial together, means that you should multiply it one by one, term by terms. You should multiply it first. You should multiply the first term by the given expression, and then you should multiply the second terms by the given expression one by one or term by terms. So if you just calculate that one, we have the following things: 3x times x squared give you the 3, let me just write the quality over here, 3x cubed. So x times x squared give you the 3x cubed. Then 3 times 5 give you 15. Then we have 15x squared as the second terms. And if you multiply 3x by 1, you have 3x. Care about it when you multiply two expressions, the constant multiplied by each other and also the variable as well. 1 times x squared give you, the next one is 1 times x squared, which give you the x squared. 1 times x squared will be x squared. Then 1 times minus 5x give you minus 5x, and 1 times 1 give you 1. So we have this expression. At the end of the day, we can simplify them and write it together. So the only terms that have the exponent 3 is 3x cubed. So we have 3x cubed as a first terms over here. The terms that has a x squared over here are two of them. So we have minus 15x squared and plus x squared, and minus 15 plus 1 give you minus 14. So we have minus 14 x squared after simplifying that one. And the another terms that is in a common is 3x. We have 3x and minus 5x. So 3 minus 5 is minus 2. So we have minus 2x, and at the end of the day we have a constant part which is 1. So right now, by multiplying the polynomial of a degree 1 and polynomial of degree 2, we reach to the polynomial of a degree 3 that you can see over here. This is a type of the polynomial. The another type of the function that we can consider it over here is a rational function, when we have one polynomial over another polynomial. So this will be a rational functions, and this type of the function, I mean the rational function and polynomial, are a type of the algebraic function. So while the previous description can be applied quite generally, we turn now to classify the small set of basic functions, and this is the case. So the another things about the rational function, you should care about their denominator. This denominator cannot be 0, because this is a rule that a number over 0 is undefined for the rational numbers. So you should care about their denominator as well. The another type of the function is roots of a function, when we have roots of given function, and if the roots is an even root, then the terms inside of the roots should be positive. Always it should be positive. For example, this type of the function can be considered as follow: f of x equal to second roots or the square root of x minus 1. Over here you can see that we have a roots function, and for sure, as I said it, the terms inside of the roots, or x minus 1 that is written under the roots, should be greater than equal to 0, should be positive. And this leads us to this condition that the x should be greater than equal to 1. If you shift that minus 1 to the right side, then we have x greater than equal to 1. And as you see, the domain of this function contains only the value that is greater than equal to 1. Otherwise, it's not defined on a real valued function. So at the end of the day, we have the classes of a function for the exponential and logarithmic function that we will discuss about that type of the function by the details later on. And also we have the hyperbolic functions that they made by the exponential functions, and we have the trigonometric function as well. This type of the function also will be discussed later on. We will discuss about the different type of them, but it's not a bad idea to just be familiar with the forms of that one: sine, cosine, tangent, cotangent, secant, and cosecant over there. And we also have the special type of transcendental function, like an arrow function, Bessel functions, gamma function, that normally we will not deal with that type of the function. But for example, Hoyside unit step function, you will see it in a ordinary differential equation, and also the Dirac delta function as well. In a physics you will face with that type of the function, and the error function as well. The Bessel function also used for making the basis for the vector space of the functions as well. The gamma function that denoted by the gamma forms is introduced on a ordinary differential equation as well. It's severally can be seen as a extension of a factorial. And we will not talk about this special function in this course too much, but this type of the function will be discussed later on by the details. In the next lecture we will talk about the exponential and logarithmic function, and also we will talk about the trigonometric cases. As I said, we have a lot of topics in the calculus, and it's need a lot of time to discuss about all of them. I will finish the first lecture at this point, and we will discuss about the remaining parts in the next lecture. Thank you for your attention.